Good day, everyone. I'm Kevin Nisukota, an electrical engineering student from UCLA. So, this topic is parallel operation of alternator. So, what is parallel operation of alternator? When the load on a system exceeds the amount of power that a single or existing number of generators can deliver, an additional generator is connected to the system to deliver required power. So this method of adding an alternator in the existing system is called parallel operation of alternator. Calling an alternator is really an easy generator. Then in alternator, an EMF is induced in the stator like the stationary wire with influence of rotating magnetic field due to Faraday's law of induction. Due to synchronous speed of rotation of field poles, it is also known as synchronous generator. So here we can discuss about parallel operation of alternator. So when AC power systems are interconnected for efficiency, the alternator should also have to be connected in parallel. So there will be more than two alternators connected in parallel in generating station. So what daily firming mag maggamit ni siya og two alternators or two generators. Kaya mag-depend po niya siya supply what. So once nga iya supply is gamay ra, pwede siya mogamit og one generator or one alternator. Mao siya nga saya o nagdepend po sa load. Kaya once na tako load, gamit siya dual generator. Then kung what if gamay dra supply or load, one generator ya gamiton. So general procedure for parallel alternator. So generator 1, generator 2 is one and load. Then so generator 1 is running machine. Then generator 2 is incoming machine. So generator 2 is parallel siya with the running power system to generator 1. So these two machines are about to synchronize for supplying power to a load. Then so kaning generator is about to parallel with the help of switch 1. So kaning switch 1 is parallel na siya sa generator 2. Then this switch should never be closed without satisfying the above condition. So what? So kaning switch niya is always ni siya on sa kaniya sa connect din sa generator 2. Then condition for parallel operation of alternator. So there are some conditions to be satisfied for parallel operation of the alternator before entering into that. So we should understand some terms which are as follows. First is the process of connecting two alternator or alternator and infinite bus bars to in parallel is known as synchronizing. So ang synchronizing is two alternator or infinite bus bar system. The next running machine is the machine which carries the load. So katong running machine mo to is about to generator 1 mao na siya ang magdala sa supply or sa load. The incoming machine is the alternator or machine which has to be connected in parallel with the system. So katong mga mosunod niya nga machine niya or mga alternator machine naka-connect to sa system which is naka-parallel. Di na siya mga condition Other condition na satisfied. First is the phase sequence of the incoming machine voltage and the bus bar voltage should be identical. So kanina mga incoming machine voltage or bus bar voltage, mao ni siya is mga naka-identical. Then the RMS line voltage of the bus bar are already running machine and the incoming machine should be the same. So katong mga nagdagan na nga machine or napay-pasod ni machine, pare-pareha sila og mga voltage. Then the phase angle of two systems should be equal. So kaning alternator 1, alternator 2 or generator 1, generator similar na siya o mga angle. So then example for case number 1. So two single piece alternator operating in parallel have induced aims on open circuits at 230 degree 10 and having reactance of G2 and G3 respectively. Calculate is terminal voltage B is power delivered by each of the alternative to our respective load of 6 ohms. So solution, so mao niya na withdrawing na ako niya one. So kaniya G2 is mo siyang Z1. Dire agi iya mo ni I1 din I2, so kaniya G3 dire kaniya G2. Dire sa iya E1 is 230 angle 0. Then A2 is 230 angle 10, then 6 ohms. So sa generator 1, formula siya I1 is E1 minus E2 times Z plus E1 Z2 over G times G1 plus Z2 plus G1 times Z2. So now your given is E1 is equal to 230 degree 0 angle, or then E2 is 230 angle 10, then Z1 is 2G, G2 is 3G, then Z is 6 ohms law. So I1 niya is 230 minus 230 angle 10 plus 230 times 3G over 6 times 2G plus 3G plus 2G times 3G is equal to 14.3 minus G 3.6. So ato siya angle is 14.73 angle negative 14 ampere. Then is ato one is the generator sa current 2. So ang formula ng current 2 is balik na siya mayroon siya E2 minus E1 times plus E2 Z1 over Z times Z1 Z2 Z1 plus Z2 plus Z1 Z2. So 230 angle 10 minus 230 times 6 plus, so na siya G derivative. Then plus 230 angle 10 plus 2G over 6 times 2G G plus 3G plus 2G plus times 3G. So for is 22.8 minus G 1.2. So I2 is 22.83 angle 3 negative 3.01 ampere. So bottom natin is bottom is para to current. So current is equal to I1 plus I2. So na I1 is 14.73 angle negative 14 plus I2 is 22.33 angle negative 3.01. So makuha ito yung current is 37.4 angle negative 7.3 ampere. So ang ipangita sa E is terminal voltage. So load voltage or terminal voltage is equal to B is equal to I times Z. So that natin I is 37.4 angle negative 7.3, then ang Z naman is 6 ohms. So the answer sa letter A is 256.4 angle negative 7.3 volts. Then sa B naman is ang current niya is each of the alternator towers give load of 6 ohms. So power delivered by first number is una is first alternator. So P1 since kaya first alternator sa gamit ay P1 times B I1 cos theta I1. So equal to ang B naman is 226 na 206.4 times 14.73 I1 times cosine 0.6 6.7 is equal to 328.83 watts. Then the second alternator is P2 times is equal to BI2 cos theta 2 is equal to 226.4 times 22.83 times cos 4.3 is equal to 5,108.63 watts. So that's for the his was a two example is. The next is the for example for case 2. Two identical alternators E and B share equally a load of 12 megawatts at 33 kV and 0.85 power factor lagging. The synchronous reactance of each alternator is 5 ohms per phase, and the armature resistance is negligible. Alternator E as its field excitation adjusted to carry 160 E lagging current, but is the current supplied by alternator B. So only example. So formula niya is, so solution is IB is equal to nadri is kanina kan iya solution iya formula nga sa formula ganiya is IT angle IT and positive angle is equal to IE positive angle IE positive angle E plus angle B positive angle B. Then which is angle ato is IT is equal to IE plus B. So three is nabalik niya solution hapon sa last. So since ang pangita diri kay IB man siya IE. So IB is equal kung ato siya IT plus IE plus IB. So ato siya i-cross multiply lang. May mo siya IB is equal to IT minus IE. So formula niya is sa IT is equal to P over square root of 3B PF. So since kaya ipakita is total, I total, so I total is PT over square root B square over square root 3 B PFT. So ang P is 15 megawatts. So kaning megawatt is million na siya. Did over square root of 3 times 33 kb. So kaning kb is thousands times 0.85 ang power factor. So ang IT niya is 308 times 3.743 ampere. So kung ito iya theta. So theta. So na iya naman power factor is 0.85. So inverse of cosine times 0.5 is theta T is equal to 31.788 angle. So IT is equal to 108.743 angle negative 31.78. So why ganong negative 3 negative siya? So since ganong negative siya, tungod man kay ang gamit is power factor is lagging. Then na kay IT. Since na kay I1 ang kulang na lang niya is karong theta. So formula is P is equal to square root of 3IB PF. Ato siya i-cross multiply. Ang PF na rin tao. So PF is equal to P over square root of 3BI. So since kaya sa email siya nga 1. So PF is equal to PE over square root of 3 times BIE. PE is 7.5 megawatts over square root of 3 times 33 kV times 160 E. So power factor is 0.2. So ito siya kaya theta. So cosine theta is PF times PF. So inverse of cosine is 0 times 0.2 is 34.915. So I is 160 angle negative 34.915 ampere. So ano, similar daw siya nga negative doon sa lagi. So, gamit sa formula ng IB is equal to IT minus IE. So, IE niya is 308.743. Angle negative 31.78 ampere minus 160. Angle negative 34.915 ampere. IB is equal to 1.49.237. Angle negative 58.435 ampere. So next example of for is two alternator are connected parallel to supply a load at 33.3 kV. The total load is 4,250 kilowatts at 0.85 power factor lagging alternator. E operates with a load of 2,185 kilowatts at 0.707 power factor lagging. Determine the current of supply by alternator B. So, simigabon ito ipalitan is B, IB. So first is ato ko niya is mga gyapon na similar gyapon siya pagi sa sarong case 1 ay sa problem 1. So I total niya is of PT over square root of 3B if B power factor of T. So 4,250 kilowatts over square root of 3 times 3.3 kV times 0.85. I total niya is 8.74.773 ampere. So next is the theta. So inverse of cosine times power factor. So the power factor is 0.85. So the answer is 31.788 angle. So I total is 874.773 angle 31.78. So same job siya. Negative 32. The power factor is lagging. Then next is the IE. So IE is equal to PE over square root of 3B times PE. Then 2,125 kilowatts over square root of 3 times 3.3 kV times 0.07. So ang IP is 525.85 ampere. Then next equal is theta. So kailangan tayo power factor. So inverse of cosine times 0.707. So answer is 45 degrees. So IA is equal to 525.845 angle negative 45. Negative job kay lagi mo. So mag-proceed na sa same job ng formula. IB is equal IT minus IE. So ang IB is ang IT is 874.703 angle negative 31.788 ampere minus 525.854 angle negative 45 ampere. So ang IB niya is 382.222. Angle negative 13.461 ampere. That's all. Thank you.